Very good evening, one and all. I am Dr. Nilesh S. Dumore, FDP Co-Coordinator and Head of Chemical Department, SN Patel Institute of Technology and Research Center, Umrakh, Bardoli, Surat. I would like to warm welcome to our esteemed experts speaker, Dr. Swapnil Dharaskar, for today's Faculty Development Program sessions. So we are truly honored to we have such a distinguished experts with us. So Dr. Swapnil Dharaskar is currently working as an associate professor and former head of chemical department, School of Energy Technology at Pandit Deen Dayal Energy University, Gandhinagar, Gujarat. He has around 13 years teaching and research experience. He worked as a SERB overseas postdoctoral researchers, Department of Green Chemistry, Labyrinth Ratna University of Technology, Finland. He invited as a visiting research scientist at Department of Green Chemistry of LUT, Finland. And Dr. Swapnil handled multiple research projects and received the fund from the DSTs, DBT, LNT, and Gush Coast on environmental and sustainable areas as a principal investigator. Dr. Swapnil has published more than 90 research papers in international reputed journals. He has attended 75 international and 60 national conferences. He has guided total 9 PhDs, 3 awarded and 6 are going on, and 30 plus MTech scholars and more than 80 plus BTech students. He is a fellow members of various professional bodies like IICHE, AICHE, Indian Water Associations, Catalyst Society of India, American Chemical Societies, Indian Engineer Institutions, Indian Society of Technical Educations, and International Society of Nanotechnology, etc. And he is an active reviewer of several high reputed international SCI SIE journals. And he has a recipients of several professional research excellent awards. And Dr. Soptil has Google citation is more than 2,700 um, citations. H index is a 29, I-10 index is a 56. So this is all about our today's experts, Dr. Swapnil Dharaskar. So now we will enjoy a healthy session with Dr. Swapnil Dharaskar. Sir, I request to Dr. Swapnil Dharaskar continue his session. So please, sir, continue your sessions.
Okay, thanks, Dr. Nilesh, for a nice introduction. And first of all, I'm very much grateful to the coordinators of this FDP, including Dr. Paul and Dr. Nilesh, for inviting me to deliver talk on such an important topic, which lies in the area of green chemistry, sustainability, and other aspects. So basically, as far as my expertise is concerned, I'm not really expert in the field of agriculture, but I will try to give you the glimpse about various case studies and the amalgamations of different research topics. So before going further, I just want to confirm my screen is visible to you, Dr. Nilesh.
Yes, yes, sir, it's visible.
Okay, I'm just trying to moving some at least one or two slides. Just confirmed. It's
Yeah, yeah,
moving.
sure.
It's
Yes,
moving.
moving. Yeah,
Okay,
yeah.
thank you. Yeah. So once again, I'm very much thankful, Dr. Nilesh and Dr. Paul, for inviting me. And it's my pleasure to deliver a talk in front of the audience. And many of the, I think, most of all are the academicians or maybe the industrialists are available in the audience. So sometime there might be a possibility whatever I'm trying to highlight, some technical errors might be there. So if you have any queries further, you please connect with me after discussion, after completion of my presentation. So yeah. So basically, I just want to cover the topic which given to me, that is greener and cleaner approaches for environmental sustainability. So basically, I'm Dr. Swapnil, currently working as associate professor and former head in Department of Chemical Engineering at Pandit Deen Dayal Energy University, Gandhinagar, Gujarat. In addition to that, I'm handling the portfolio of the dean placement as well. So my research interest lies in the three key areas of engineering, which includes nanomaterial study, ionic liquid study, and CO2 capture study. As far as my PhD work and postdoctoral work is concerned, I did lots of work in the area of ionic liquids and just a minute, in the area of ionic liquids and their modeling and simulation aspects, currently one of my research group is actively involved in DES, and we are working hard to work on the CO2 capture. And apart from that, we are also working in the area of nanomaterial study. So before going further, I just want to acknowledge my, innovation, yeah, my country partners and industry partners who always supported me to take a lead for different types of project work, and they're supporting me to go for the techno-economical scalability of that particular project. That's why, you can see Professor Mika Silenpa. Basically, he's my postdoctoral supervisor as well. Then from Professor Chang Kyo Yu from Kyonghyun National University, South Korea, Indu Pandey from LTTS, and Apar Industry, Dr. TCSM Gupta. Apart from that, there are several collaborations. We are working on multiple areas. So before going further, I just want to highlight that we are trying to cover a few important aspects, which is highlighting the nanomaterial applications, and specifically in the field of agriculture also, and in general in the field of environmental sustainability. So as we all know, that there are, many of you might be knowing that nanomaterial applications, basically it's a, nanotechnology is a very important technology, and I'm trying to give you some case studies which might cover, biosensors, biomedical proper, biomedical applications, water purifications, and antibacterial application as well. But since my topic lies in cleaner production and greener approach, so I just want to give you some glimpse about some, some basic idea about cleaner production. Yesterday, I heard the talk of one of the experts. She has covered multiple things about, green chemistry and sustainable chemistry. So in the similar line, I'm just trying to give you some glimpse, at least for next 5 minutes. I'm just trying to highlight some of the slides, which is highlighting the cleaner production techniques and their applications. So as an engineer, we all know the cleaner production is the continuous application of an integrated preventive environmental strategy towards processes, products, and services in order to increase overall efficiency and reduce damage and risks for humans and the environment. So as we all know, being a chemical engineer, our major, objective is to minimize the risks for humans and make our environment very sustainable and very healthy. So if we talk about this cleaner production, this thing, then environmental strategy, then risk reduction, then humans, environment, these all are the key components of the cleaner production. In other words, there are, cleaner production is a tool to answer three questions. One is assessment to the options to the less waste, and less waste to the improved productivity. So these are the three important key questions where the entire cleaner production methodology and the technology lies, and we are trying hard to work on those things to make our earth very sustainable and our environment, free from the various elements. So if you talk about 7 key points, so CP adds value to the MES. CP stands for cleaner production. So basically, it adds value to the environmental management systems by emphasizing on pollution prevention rather than control, with clear improvement in environmental performance. CP does not deny or impact growth, but insists that growth can ecologically is sustainable. Again, it is limited only to manufacturing industry of a certain type of size. It can be applied towards the provision of services as well. CP includes safety and protection of health. It includes emphasis restoration, improves immediate efficiency as well as long-term efficacy, and it's a win-win factor with the benefit for the environment, communities, and business. Now, this schematic can easily give you the idea why the relationship with different multilateral environmental agreements. There are multilateral environmental agreements that made by the various agencies, and that indicates how the cleaner production categories are there. Let's say, for example, if we talk about UNFCCC, Kyoto, which sheds greenhouse gas emission, then Basel Convention, waste minimization, Stockholm Convention, avoid unintentionally produce, this PCBs, dioxins, and furans. So this particular schematic can easily give you the idea about the importance of cleaner production techniques. As a second part of green chemistry, we can talk about the solvents. As we all know, solvents plays very important role in the field of technology and the engineering, right? So this particular solvents can give us many opportunities for the improvement of environmental aspects. The solvents can represent very large proportions of the VOCs released into the atmosphere. And UK, if you talk about UK solvent markets, so around 4,000 pounds million per annum, the market of UK is there in terms of the solvents. I can cover up one case study which is highlighting the facts about the CO2 market, where Our research group is extensively doing lots of work in the area of CO2 conversion into value-added product. Then, if we talk about alternative solvents for synthesis, where we can say there are three categories. One is synthetic chemistry reaction, where we can say reaction medium on laboratory and industrial scale, extensively used in the workup and purification purpose. As far as analytical chemistry is concerned, we have to think about sample extraction, spectroscopy, chromatography, where mobile phases are there, and crystallization, recrystallization to purify compound and prepare crystals suitable for analysis. Again, there are multiple applications of solvents, which includes coating, where you can say paints and adhesives, cleaning, dry cleaning, yes, and extraction. As far as the topic, the food and the topic of this FDP is concerned, food and other aspects, where we can say coffee decaffeination, which comes benzene and chloroform, where these solvents are able to extract and use. Again, as a reaction media, yes, it can be used for the energy control. And again, where you can say endothermic reactions requires energy, exothermic requires reactions always. Solvent acts as a heat sink, preventing runaway reactions. It can be removed by allowing solvent to boil, effective mixing and stirring, and addition of solid reagents as a solution. So current approaches to the solvent replacement. Yes, this is very important slide where we can say it's very difficult to simply replace one solvent with another solvent. We cannot replace the solvent very easily. We need to understand the proper, the compatibility of the solvents with the reactions, and it's very difficult for us to, we cannot simply replace the solvent. So as far as the process is concerned, not just one aspect where solvent used in workup and purification, not just as a reaction media, it can be useful for multiple other objective point of view as well. Many aspects must be considered and their relative importance determine quantitatively matrices. Now, what is the process used to prepare the solvent, which never minds about intended use? First is energy. Second is one is hazardous processes. Third is raw material, and fourth one is byproduct. Then again, no solvent, water. Anyway, so this is not that much important. But if in overall summary, if I say the current approaches for the green chemistry and the green production approaches, all are the advantages and have some disadvantages, which needs to be considered when assessing suitability for replacement. So based on that, I have just prepared some of my slides, which can give you some idea. And I'm just trying to give you some glimpse about a couple of minutes for nanomaterials. Then I can show you what exactly our research group is doing in that part, and then how there's applicability. And I can cover up a few case study, which is really interesting for your upcoming research point of view and upcoming projects point of view. As we all know, nanotechnology, yes, is a science and engineering and technology which conducted at the nanoscale. Everybody knows that nanoparticle termed as 1 nanometer material size, the particle between size of 1 nanometer to 100 nanometer. And this particle, we are focusing on nanomaterial as these are already being used in workplaces more widely. Now, the nanoparticles can occur naturally, and it can be occur naturally. It can be produced by human activity, either as a product of another activity, or sometime as an engineer, as a researcher, we develop some nanomaterials specifically for purpose. We are having some purpose, application related purpose, then we need to go for the on purpose, where engineered nanomaterial as these are designed and integrated into products because of this specific characteristic of the nanoparticles. Now, there are multiple types of nanoparticles. I'm not going into that much detail. There are two different approaches and very basic approaches which can be used applicable for development of nanomaterial. One is top-down approach. Second one is bottom-up approach. This is the way where we can say how we can bifurcate or categorize the nanomaterials, where bulk surface, then particles, surface-bound particles, suspended in liquid particles, suspended in solids, and airborne nanoparticles. Basically, as we all know, there are different category of the nanoparticle. One stands for 0D, second 1D, 2D, and 3D nanoparticle. I have given some of the examples also. For example, if we go for carbon nanotube or some type of nanowires, it comes under the category of 1D nanomaterials. Thin film shades, 2D nanomaterial, where we can say graphene thin film. Then MXene comes under the category of 2D. Our research group, extensively working in the area of graphene and MXene for multiple applications, Recently, one of our, one of my PhD scholar graduated, and he has done lots of work in the area of graphene and amexine for the water purification. And again, we can go for 3D kind of nanoparticle as well. This is the layer materials, like including graphene family, where we can go for graphene oxide kind of nanoparticles, 2D based nanoparticles, where you can see different types of materials, 2D oxide based nanoparticles that can be developed for multiple applications. And nano is having lots of applications in the area of agriculture and food industry as well. Now I'm just trying to give you some schematic. This is the schematic route. We are doing some work with Sunway University and University of Leicester, UK, and we are doing joint work in line with graphene development and MXin development. So you can see different types of steps. Which one is synthesis of graphene oxide. Second, we are utilizing the approach of microwave synthesis, and then third stage is mixing and filtration, and finally we are able to get a thin film, graphene thin film. Again, nanomaterial synthesis, there are various ways and various materials. It can be categorized based on the method of the synthesis and their approaches and applications. Yes, this is something really interesting. As I mentioned, that we are doing some research with Sunway University, and the basically the founder of the Amexin, Yuri Gogasti, he's working with Drexel University. He highlighted the capabilities of the Amexin, and it's really interesting topic to work on. So basically, Amexin link can be printed onto the almost any surface, and they don't require any additives. So there are some unique properties of MXene, and that's why nowadays MXene is having a good applications. And many of the researchers, basically from chemistry background, they are really working in the area of MXene for the various applications. So being an engineer, we can also go for it. And as I mentioned, one of my PhD scholar already developed many titanium based carbide based MXenes for water purifications applications, and we are also trying to explore the applications of MXene into the CO2 separation and possibility for CO2 conversion as well. So there are certain properties of this MXene. You can see it's a layer of multiple layer of this one. So it's a structure of the various layers, and application, as I mentioned, it can be used for energy storage, catalysis, electromagnetic, electronics, mechanical, tribology applications. We have connections with apparel industry and other fuel-based industries where we are trying to identify the applications of MXene for tribological behavior of the fuels and other properties of the fuels. Environmental applications where we can say in the field of agriculture, in the field of food industry and others. We can also think about the MXene for sensors and biological applications. As we all know, now we are going for Industry 5.0. Many of the industries already implementing the concept of Industry 5.0. As of now, if we talk about the academia, we are still running with 4.0, right? There are multiple applications of robotics and cyber physical systems and other things. But basically, if we talk about that aspect, then in days to come, the biotechnological innovations might create a good impact in the future ready solutions and future ready options. As we all know, robotics, yes, since I think last 10 years, we are really improvising ourselves in the field of the robotics, but that is not really popularized in India. But in days to come, that is again one more field which can be very spread out. I think many of you know that in the country like Canada, US, the already man-made cars are these the unmanned cars are there. Without the intervention of human being, the things are getting, for example, driverless car, driverless vehicle, many other things are happening, and that's really very good options. And maybe in next few years it will be applicable in India. I think just few days back I heard the news that in Bangalore, one of the industry already launched something, and that in line with a similar concept. And mostly after getting the government trials, it will be soon implemented in the Indian market as well. So this is something the progress towards macro scale applications. I don't want to go into that much depth. Yeah. Now this is something which which where I'm trying to just highlight what kind of work we guys have done at PDU, and what is the contribution of the students and how they have really performed. I'm not trying to give you the glimpse about, for example, the SEM graph, XRD graph, TANG graph. That is not my role. I'm just trying to give you the idea about their overview about their applications, and why that kind of catalyst, why that kind of material is really creating the impact in terms of some applications. As I think many of you know the concept of nanocatalyst. Basically, nanocatalyst, see, catalyst, everybody know there are different types of catalyst, homogeneous and heterogeneous. But if we develop nanocatalyst, that can give you a good efficiency and good in terms of application, that catalyst act as a promising nanocatalyst. So if we look into the parameters where we can say the nanocatalyst can really help, one is improved economy, second energy efficiency, third is a reduced global warming, high activity and selectivity. If we talk about nanocatalyst, these three important parameters, one is high activity and selectivity, then minimum chemical waste. Yes, this is something really important as far as if we talk about cleaner production or cleaner technology. Safer catalyst and reagents, it can be easily separable, external stability, enhanced surface area. So these all are very important parameters which makes the catalyst, nanocatalyst, very promising in any application, right? So our group I already developed some nanocatalyst, and we have finished one project with LTTS where we have given them the unique catalyst which can able to convert uh, as carbon dioxide, CO2 very easily into the methanol with high purity of methanol. So we have done with one project with LTTS. Almost it was 2 years project, and they given us 1.5 CR funding, and we have completed that project successfully, and it is really getting executed in the market very soon. If we talk about the applications of nanocatalyst, where we can say it can be applicable in water purification, fuel cell application, then solid rocket propellant, biodiesel production, drug delivery systems, photocatalytic activity, and environmental protection, and thin film solar cell, and again nanotoxicology. So there are multiple applications of nanocatalyst, and being a chemical engineer, being a mechanical engineer, being a biotechnologist, being a chemist, everyone can easily use this nanocatalyst for various applications, right? So that's why there's a uniqueness of this catalyst, and I think many of the industry already implemented the concept. Nowadays, they are going for development of nanocatalyst rather than going for catalyst. Simple catalyst can give you the efficiency up to 70 to 75%. But if you tune that catalyst and make that catalyst as nano, then the efficiency is really getting improved, improvised up to 90%, up to 95%, and that gives you a good separation in terms of the industrial applications point of view. Now, if we talk about the biomass gasification, I think just Dr. Meghal Desai already given you the idea about the microwave assisted process, the uniqueness of that particular process. So biomass gasification is a one gas, it's a conversion of biomass into the high value product, is one of the solution to produce energy to meet high energy demand. Nowadays, everyone think about the energy because we are trying to focus on energy aspects, and that's why our university, basically the name of our university lies in energy university. So the mandate for all the faculty of this university, they are trying to work in the line and align with the energy requirement and the energy demand. The most efficient conversion would require minimum or no quantity of tar to produce as a byproduct. So if we talk about this biomass gasification using nanocatalyst, so the role of nanocatalyst, it can minimize. Basically, as we all know, uh, the moment when we prefer the gasification, there's always possibility of tar formation and some byproduct which can be, which cannot very easily decompose, or it's very difficult for us to, uh, let's say, let's say maybe decompose that particular material. And here, if we go with the nanocatalyst, which have been successful to obtain the products at lower temperature as well, and given us a good resulted in a reduced tar formation. They have also improved the quality of gas formed, whatever the quality, because the moment when we go for pyrolysis, there are multiple gases they are coming out, and we need to understand, we have to cross verify the purity of those gases. If that gases are having very toxic kind of toxicity, or concentrated gases are there, that will cause the problem to the environment. So that's why this particular nanocatalyst is really good and improved the quality of gas form. Again, the problem of carbon falling and sintering is also getting reduced. That is really important to minimize the carbon footprint. And various nanocatalysts like zinc oxide, then nickel oxides have been used for gasification. And this kind of catalysts are easily synthesized at our lab as well. We need to tune the property and make that catalyst at nano level. Now, I think biodiesel production, many of being a chemical engineer, it's a very popular terminology. Uh, and biodiesel is usually produced by transesterification reactions in the presence of catalyst. As we talk about a conventional catalyst, because lots of research already done in the area of biofuel, biodiesel and biofuel production. Nowadays, if someone say that I'm working in the area of biodiesel, then first the researcher like us, we ask what is the novelty and what is the uniqueness of your methodology, because all types of catalysts have been formulated, have been established, developed, and all. So we have to think how to tune and functionalize all the catalyst, which gives us some add-on properties and makes the process very promising. So use of conventional catalyst may incorporates the problem to compromise either with the yield, quality, or the efficiency of the process. Yes, the moment when we go with conventional catalyst using the transesterification process, that is there, there may not be a possibility that we are able to get a good yield, or quality of the product may not be good, and it will affect on the efficiency of the process as well. But the moment when we go for nanocatalyst, where we are able to save the reaction time, increase the rate of mixing, faster recovery of catalyst to give a better process. And that's why there are some commonly used catalysts for biodiesel productions are like calcium oxide, zinc oxide, aluminum oxide, magnesium oxide, and other different types of base nanocatalysis. So this type of catalysts are commonly used for biodiesel production. If you look into this schematic, you can easily understood one side. If you talk about base nanocatalyst, acid, and bio, this can give you a good unique properties and high activities for to enhance the flow of production of biodiesel. Excuse me, please. Okay, so I'm just trying to highlight some of the recent research activities which lies in the biodiesel production. One is development of catalyst. One side you can see the researcher developed the catalyst, how this catalyst is improvising the yield. Let's say one catalyst is giving us 96.8, this catalyst giving us 90 to 97%, and other catalyst giving you 98% kind of yield. Here you can see these the characteristics of the nanocatalyst. You can easily visualize. I don't want to go through the line to line, but see, if you look into the nanocatalyst, this catalyst gives you 98%. But zirconium oxide loaded potassium bitractate nanocatalyst, even though it is applicable, it is giving you a good effectiveness for biodiesel production. Still, industry may not prefer because of the zirconium and potassium kind of involvement. But but they can easily go with calcium oxide, or they can easily go with titanium oxide kind of nanopart material, even though efficiency lies between 91 to 96.8%. Now, recent innovation, if we talk about recent innovation in the field of biodiesel, where the magnetic nanoparticles or nanocatalyst that has been developed, and one of the recent innovation is the usage of nanocatalyst having magnetic properties. This properties eases very easily make the separations of nanocatalyst in the presence of external magnetic field with minimal loss. You can see the schematic. So with the help of magnetic kind of nanocatalyst, we are able to separate. The separation is getting very easy in the field of biodiesel. That's why nowadays many of the researchers who are working in the area of biodiesel and biofuel, they're trying to go for magnetic based kind of nanoparticles, and lots of commercial applications are there. Many of the industries already commercialize the nanocatalyst for their own own companies, like including petroleum refining, petrochemical industry, polymer manufacturing, pharmaceutical, and food processing. So many of the nanomaterials having the possibility to meet the future demands in all these sectors. Now, this was about nanocatalyst. I just want to highlight and touch upon second part and second applications of nano, which is in water treatment. Again, it's a very common kind of common everybody knows about different types of water purification systems and water purification technologies, and the and and various applications of the membranes. If we talk about the current scenario, there are many conventional processes already implemented and established, which includes coagulation, ozone, membrane, lime softening, biological treatment, filtration, precipitation. And if I say As per the data, approximately 40 to 50% of the wastewater generated in India is being treated daily. 40 to 50% wastewater generated in India is being treated daily. It means it's a huge amount of water that needs treatment. So, so if we talk about the drawbacks of the conventional technology or the processes, there we can easily visualize most of the methods available in the market, or maybe the existing methods are there, either adverse impact on the human health or ecosystem and are not so environmental friendly. That's why second point is generate secondary pollution due to the formation of byproduct. Again, time consuming process is the main cause. Hazardous gases generation, sludge formation, and RO removes nutrients, important nutrients and minerals. Then apart from this, the wastewater generated and treated following are having some problems. One is, again, we are facing the issues with, again, this, there is no control, increasing population, depleting water resources, and the third important point is climate changes resulting in prolonged drought and flood. Okay, hence the requirement of stable, more economical, effective, and reliable method is increasing day by day. So government of India, as we all know, investing lots of amount, not really, in last 5 years, but in last 25 years, different parties invested huge amount for the water purification, water treatment, and they're trying to hard to develop very promising technique which gives them a very good separate, water purification, and they're able to solve that problem. We require highly efficient. So based on all the statistics, if I want to say, then we all require a highly efficient, modular, and multifunctional process to provide high performance and affordable wastewater treatment. So nanotechnology is a one solution. I'm not saying it's 100% a correct solution, but yes, based on the lots of case studies, not even within India, outside of India also, many of the prominent researchers, they highlighted the nano is the one where we can say it can give you a good techniques in the field of water purification. And there are multiple novel nanotechnology which includes nanosorption, nanofiltration, photocatalysis, disinfection, and microbial control. I'm not going into that much detail. I'm just trying to highlight what types of nanomaterials and are very important and very effective to remove the different types of heavy metals from the stream. For example, what makes nano very unique? Larger surface area, which gives you a good chemical reactivity, good selectivity, enhanced surface chemistry, and improved kinetics. So these few properties makes the nanoparticle more promising for any kind of applications. So if we talk about the water applications, if I'm trying to focus on one of my PhD scholars, she has done a huge amount of work where she has developed multiple very different types of nanoparticles, very unique nanoparticles, and functionalized nanomaterials, and trying to minimize different types of heavy metal from the water stream, which includes lead, then chromium, 6, arsenic, cadmium, nickel, mercury, uranium, whatever. But our major, as far as my research is concerned, we are focusing on chromium, cadmium, arsenic, nickel, fluoride, and lead and mercury. So so the novel adsorbents, where we can go for polymeric based nanoadsorbents, metal-based nanoadsorbents, bioadsorbents, and carbon nanotubes. So if we go for the modified graphene oxide, fluorines, nanodiamonds, and carbon nanotubes, this can give you a good results in terms of purification systems. Again, a lot of metal nanoparticles or transition metal complexes have been used as an adsorbent for the removal of variety of pollutants from the wastewater. Look, why I'm trying to highlight the facts about the wastewater, because somewhere the water is really needed for the agriculture stuff. And if we want to recycle the industrial wastewater and make that water into the potable water, which can really useful for the agriculture point of view, that's why we need to minimize the highly toxic elements from that wastewater. Otherwise, that will create the problem for the agriculture sector. That's why this kind of the nanotechnology and this kind of nanoparticles play a very important role, and giving us a good separation in terms of all these metal ions, which copper, cadmium, arsenic, chromium, lead, and dyes and phosphorus contaminants. Apart from this, we have also developed magnetic kind of nanoparticles where we have developed few nanoparticles, like including iron oxide nanoparticles. Even I tried, one of my research scholar tried with the combination of the iron oxide and the ionic liquid. We got published one paper, but there was one comment that really pinched me, because look, ionic liquid given a good promising efficiency in terms of water purification as well, but because of the cost of the ionic liquid, we cannot go for we cannot make that technique commercialized because it is not really affordable and not really comfortable. But if we talk about the result, you can refer that paper of mine. It is available on the Google Scholar. So if you let's say talk about the ionic liquid involvement in the water purification, it will give you a good separation and purification efficiency in comparison with all these nanoparticle. But unfortunately, because of the cost and other parameters, we cannot go for the commercialization of that techniques. Again, this is a common kind of adsorbent, carbon-based adsorbent. Bioadsorbent, yes. One of my researcher, she has done work in the area of nanokitosin. We have developed nanokitosin based adsorbent for chromium 6 recovery from the various industrial stream, and then we have published good papers in high impact factor journals. Nanofiltration, photocatalysis. These are some important metal nanoparticles can be applicable for the purification. One is magnesium nanoparticles, gold nanoparticles, and silver nanoparticles. Again, yeah, nowadays, I think not really nowadays, maybe since last 5 to 6 years, we have seen that zeolite is another family which can really creating a good impact in the research, where we can say zeolite based nanoparticles are laser induced fragments which has shown effective sorption ability and ion exchange ability for metal ions. They are porous structure. It look as a membrane, and it can be really accommodate variety of cations like sodium, potassium, magnesium, etc. and all, and can be easily used for ion exchange. I think in the previous years we use resin kind of material to just simply clean the water, but here this is just like as a similar one, so it can be easily applicable for the ion exchange membranes and all. Experiments have shown that zeolites are even efficient in removing heavy metal ions. Yes, we have developed different types of MOF 7, MOF 8, MOF 11, MOF 16, and different types of zeolite materials that we have developed, and we have implemented all those materials very successfully in the area of wastewater purification, water purification. And in addition to that, we have developed some MOF and encapsulated those MOF in with the membranes, and we are trying to highlight or maybe increase. We are trying to improvise the efficiency of CO2 separation from the mainstream. So this is again okay. This is all about zeolite. Then again, yeah, solar cell. Again, if I talk about this solar module, basically, uh, actually, I just want to highlight the idea about this solar because I'm just getting fascinated with one technique. As we all know, solar nowadays, solar is very common, and every government is really pushing a lot for everyone to go for the solar based energy concept, and many of us already brought it and and successfully utilizing it as well. If we talk about innovation is made to manufacture dye-sensitized solar cell which use the concept of nanotechnology, and they are less expensive and quite flexible. Because if we talk about a conventional solar panel, it's quite bulky. It's not once you've established, it's very difficult to move, assemble, and everything. So the researcher developed a flexible kind of flexible kind of solar cell, which can give us a very good flexibility. Even if I thought today, let's say for example, if I want to stay at one location for next 1 month, I can easily at least make some arrangement, and I can easily use that solar panel and try to set up my own energy storage device. But here, the concept of nano lies where the semiconducting TiO2. If we talk about this outer line, you can say this is dye-sensitized TiO2 nanotubes. These nanotubes will enhance the conversion factor and able to track the more solar radiation and converting into the solar energy. Look, this is the regular solar cell where you can able to see how the efficiency is there. And if we talk about the nanocrystal solar cell, where we are able to get, conversion is very good in terms of solar into the electrical energy. Now, this is one concept again is very important. Like scientists have invented a plastic solar cell that can turn the sun's power into electrical energy, even on cloudy days. And the new material uses anyway. This solar cell consists of nanorods dispersed in the cell and present in a layer between electrode. The important part is cadmium selenide, which is having the diameter of 7 nanometer and length of 60 nanometer. This is very important and this is very useful nanomaterial in plastic solar cell. Now, if we talk about the disadvantage of this conventional solar cell, then we can realize it cannot be applicable in the cloudy days. But if we talk about the plastic solar cell, this can give you the solar power into the electrical energy even in cloudy days. That's the uniqueness of this plastic solar cell. And many of the Western countries already implemented this concept. I think many of the metro cities, including Bangalore, Hyderabad, we can find this kind of bus stations. We can find this kind of this thing nowadays, since the electric vehicles are there. So to charge the batteries, we can able to use this kind of solar cell, and it is getting more popularized. Very soon, it will be popularized in India also. I think maybe a few industries already implemented this concept, but this is quite popular in the country like Canada, US, Australia, and some other developed countries. So if we compare the plastic solar cell with the conventional one, they are 30% more efficient than the conventional solar cell. Again, if we talk about conventional solar cell, have bulky solar panel, while these are very compact and very flexible, and have potential to turn solar power into clean, green, and consistent source of energy. Even if we talk about if this kind of things are getting very feasible in days to come, then we can set up our own energy storage devices at any places, because the sheets are very flexible. We can easily apply the sheets and get the things done in terms of the energy conversion. Now, as I mentioned, Hyderabad-based international, there is a center of Advanced Research Center for Powder Metallurgy and New Materials (ARCI) has already developed self-cleaning solar panel, adding another breakthrough in the solar industry. The institute has used nanotechnology to build solar panels that are capable of cleaning themselves. Yes, if we talk about these devices, it is capable to clean themselves. This sometimes it's a quite it's a difficult challenge in a conventional solar panel. Again, the principal coat on the surface of the solar panel is highly waterproof material that prevents dust particle to settle on the panels. So likewise, there are multiple applications and many things are getting commercialized, and it's really useful things for the nation, for overall development of a nation. Now, if I talk about the barriers, yes, we can say the cost. Sometime we can say the cost of nanoparticle is high. Some of the nanoparticles are toxic in nature, not really much toxic, but slightly toxic in nature. That might be create some risks of the potential human health, hazardous and risks. That's why some whenever we are going for preferring the nanoparticle, we have to be very careful and need to understand the properties of those nanoparticles, and then only we can go ahead with that. Now, these are two, as of now, I have covered two different vertical. I'm trying to highlight more facts about nanotechnology in water purification, in, nanocatalysis, in biodiesel production. Now, third important point is where currently my research group is extensively working. We are really working a lot in the area of CO2 conversion, CO2 separation, CO2, utilization as well. And because we got much funding. Recently, I have received funding from Sajjan India. Also, they given me a fund. DST already given me a fund. LTTS or LNT also given me additional fund this year. They have given us 90 lakhs to develop, to scale up whatever work we have done. We are trying to scale up that particular things. So they given us good funding. So maybe we are, making the handholding with the APAR industry. There might be a possibility that we are able to get something from APAR as well. But we are always, in continue, connections with the companies and trying to understand their requirement for the CO2 conversion, CO2 utilization, and CO2 separation. I'm just taking 15 minutes more to give you the glimpse about on the concept of CO2. If you look into this slide, you can easily visualize that there are different industries, and they are how they are contributing in terms of the greenhouse gas emissions. So if we say energy industry, 24.2%, transportation industry is 25.8%, manufacturing 14.2, manufacturing industry again 11.6, means big scale manufacturing, small scale manufacturing, other industries are there, and there are some fuel and figurative emissions kind of industries which again contributed for greenhouse gas emissions. Now, as we all know, the effects of global warming and the causes. First cause is rapid industrialization, energy use, agriculture practices, deforestation, consumer practices, pollution, transportation. So these are the causes of global warming and their effects. As I think, as an engineer and as a layman, we are very easily understood the effects of global warming, which stands for temperature rising, sea level rising, unpredictable weather patterns, increase in extreme weather events, loss of wildlife and biodiversity, land degradations, and so on. If we talk about the global temperature increasing, I think nowadays we have seen that difference. The climate is getting changed at any time. Sometime cold, we are feeling cold. Sometimes we are feeling rainy. Even though there is no rainy season going on, still the heavy rainfall is on. So likewise, this is just happening because of the various parameters which causes the climate change or maybe the global warming. And if we look into the global temperature increasing every 2 years different, you are able to see zero point 0.2 degree is getting increased. For example, fifth to 25th, I'm just giving you the statistics of last 10 years where we can easily visualize. In 2014, it was zero point 0.4, then again zero point 0.6, zero point 0.8, 1 degree, and 1.2 degree. Maybe we are now 2024, it comes around 1.4. So what I want to say, in every year we are slightly, in every 2 year we are increasing. The temperature range is increasing by 0.2%. If the things are getting going on a similar direction, then there might be a possibility in next maybe 50 years down the line we are able to face a huge crisis in terms of the temperature rising and all. That's why as a researcher we have to do something. And as we all know, government of India trying to minimize the CO2. We want to make ourselves as a net zero. Initially, we decided to go for 2050 because the other countries said that 2030, 2040. But now, since other countries are saying that we are unable to uh, achieve net zero emission they claim they are going to achieve the net zero emission by 2050. That's why India set the targets by 2070, right? But still, believe me, lots of research is going on in India, specifically on CO2 reduction, and our government is putting lots of best effort how to mitigate, how to minimize the CO2 and all. So, but we have to gear up our things in terms of research, where we can say we need to switch to a lower carbon economy, increasing system efficiency, implementing carbon clean solutions technology. This is something is very important, and that's why many good companies are getting tied up with many good institutions and research body. They are trying to work together with academia, industry, and government, where they are trying to solve this problem, and we want to save our mother earth in a sustainable way. Yeah, if we talk about the atmospheric CO2 concentration, in 2017, it comes around, let's say it was around 405 ppm. But if I talk about today's statistic, it goes around 425, sorry, 420 ppm. And maybe by 20, I think maybe by today's, if we talk about it, comes around 425 ppm. So there's a huge amount of CO2 concentration is there in the atmosphere. And this is just happening because of lots of industries and the government implementing many things, smart cities concept, lots of deforestation happened, and that's why something is really responsible. But anyway, uh, yes, one side we really need to think about the development, but one side we have to also think about how to how to mitigate and how to minimize the CO2 emissions and able to solve the problems of CO2 this from the globe. Now there are multiple options. If we think about carbon capture and utilization, this one, there are multiple. One is like CO2 sources, where we can say fossil fuel, natural CO2, high purity, industrial CO2. Another one is capture options. There are different options like pre-combustion combustion capture, oxy-fuel combustion capture, chemical looping combustion, post-combustion capture, and if we talk about their utilization, where we can go for chemical synthesis, carbonates, energy products like methanol, hydrocarbons. Our group is working in this particular category. CO2 injection, yes, one of our another group is working in CO2 injection into UR, enhanced oil recovery, and some other parameters. So Now, if we talk about the necessity and what are the drivers and trend for this sustainable methanol, one is necessity. That means environmental driver need to reduce CO2, need to reduce air pollution. Yes, if we reduce all these parameter, I think if we talk about the API index of Delhi, it's very getting high nowadays. Not really Delhi, multiple cities, multiple metro cities feeling even sometime at district level also we are feeling the air is not good because of lots of issues, right? Lots of things are going. One gentleman is having multiple cars. Again, standard of living is getting increases, the facilities are getting increases, multiple things are there. One side we are talking about electrical vehicles, but we need to think about the air importance parameter as well. Again, government needs to implement the policies in a regular way, and the policies will be in place so that we are try to minimize all this thing in time. And technology, yes, there are multiple good technologies available in the market, but we need to understand which technology is more promising and give us a good efficiency. Now, I'm just trying to give you the glimpse about uh, our research group work. Basically, I'm not highlighting any of the figures and facts. Whatever work we have done, it available on the web, on the Google Scholar. You can easily refer the paper. I'm just trying to give you the idea why we went for this kind of research activity and why the industry needs for it. Now, if we think about why methanol, methanol can serve as a convenient energy storage medium. Yes, everybody knows methanol as a it can be used as a solvent, but apart from that, it's not really as a solvent, but it can be have lots of application, and that's why nowadays it's a very you know important compound for industrial point of view. One is easily transportable fuel, is a good solvent, building block for producing intermediates and synthetic hydrocarbons. There are several uses of methanol: formaldehyde, acetic acid development, dimethyl terephthalate, methylene chloride, dimethyl fuel bending, biodiesel, methylene to gasoline, and multiple uses are there. That's why the demand of methanol, is getting increased in the market. Okay, everybody knows about the properties. Yeah. Now, if we talk about the rapid growth in the global market, so in the last 10 years, methanol production capacity and use have more than doubled. We can say from 40 metric ton to 100 metric ton. Around two-thirds is used in the production of chemical products and one-third in the production of fuels. So recent applications such as methyl to olefins for plastic growth are growing even faster. So that's why, as we all know, methanol is really applicable in many different areas, and that's why the growth there is a rapid growth is happening in the global market, and there's a need of the methanol, and that's why every industry are they just trying to convert whatever the CO2 are there. Getting emitted from the stream, they want to convert that CO2 into the methanol and convert into the valued product and utilize the captured CO2 for the methanol conversion. Global market demand, you can easily visualize what is the demand by 2021, 29.4 US dollars is there. And then if we talk about 2025, 34.6. Likewise, if you go up to 2020 by 2028, the demand is almost double, 38.9. It's a high demand. Then there are certain sustainable routes, certain approaches where we can able to convert CO2 into valued product. And here we had given that approaches. One is catalytic route, then heterogeneous catalyst, homogeneous catalyst, photoelectrochemical catalytic, photochemical catalytic, and electrochemical catalytic. These are the various routes you can see. Now the methods, there are different methods. If I talk about this method again, it will take much time. But you can see one is chemical method, electrochemical method, photochemical method, and electrochemical method. Normally, we are dealing with in our case we are dealing with electrochemical and the chemical method for the conversion of CO2 into the valued product. How do we make methanol step towards carbon neutral production? One is and natural gas base this steam reforming process, we can say steam methane reforming of natural gas or coal gasification. 95% of all current methanol production less than 0.3 ton of CO2 emission for each ton of methanol. So the industries prefer SMR. If we combine natural gas for RES means renewable energy source plus CCUS technology, then it's a well-proven concept, not really practice it. No, we cannot say like that, but many of the industries and many of the academia are really working on nowadays to make this technique more proven, and just they just want to set a benchmark why this technique is really good for the production of methanol and variable CO2 emission for each ton of methanol. Again, renewable feedstock electrolysis. Yes, this is again one of the proven technique where we can say water electrolysis is a derivative of proven chlorine electrolysis, carbon neutral, negative methanol production, and everything is there. Methanol process from different feedstock. Yeah, different feedstocks are there, and you can see the entire workflow of methanol. Again, as nowadays the green hydrogen is again a very hot topic to work on. Some of our researchers are working in the area of green hydrogen, and but normally we have done good amount of work for the CO2 conversion to the methanol one. And these are some technology suppliers where we can say uh, of methanol, where we can highlight Syntex, the Logi, Mitsubishi, Haldor Topse, Linde, and all. So these guys are also having the market for methanol. Methanol production by technology. If we talk about Logi, it will contribute at 5%, Syntex 60%. The major contribution of this methanol production by technology is having with Syntex, then 27% with others, then 8% with Mitsubishi and other good companies. Okay. So if we talk about that, the advantage, the use of non-fossil fuel sources is the first advantage. Then avoidance of CO2 sequestration, which is expensive. Second advantage, and mitigation of greenhouse effects by effective recycling of CO2 is the third advantage. So because of for this three advantage, we can go for the conversion of CO2 into the methanol. There are different types of catalyst. I have just given you some. These are all the basic catalyst, but see, the industry already developed very promising catalyst, and we have also done some work for them. But these are the regular catalyst and effective catalyst that can be used for CO2 conversion into methanol, where we can say zinc oxide, alumina, then zinconia oxide, alumina base oxide. Again, the combination of two different nanoparticles. If we talk about their features, this catalyst can withstand high temperature and high pressure, high selectivity, high activity during lifetime, maybe 2 or 3 years life cycle, very efficient interaction between component in catalyst system. This again another advantage of some catalyst. Yeah, I just want to highlight about this plant. Uh, yeah, wait. This is the you can see this. This is George Ola CO2 to methanol plant. It is in Iceland. This plant is first commissioned in the year of 2012, upgrade 2015. That time the installed capacity was around 4,000 ton per year methanol. CO2 conversion 5,600 ton per year CO2. Electrolysis 6 megawatt best load. But if you see the today's the situation of this plant, then you can easily visualize there are multiple. They have expanded a lot, where we can say renewable methanol produced by chemical. Okay, you can see hydrogen made by electrolysis and carbon dioxide are again catalytically react to convert into methanol. CO2 and power from geothermal. They also implemented geothermal, and methanol can be used in a both internal combustion engine and fuel cell. So likewise, this plant is getting improvising and expand in a decent way. Okay, so this is the general generic route or the mechanism, or we can say the for the conversion of the methanol in CO2 into methanol. CO2 source, CO2 capture and cleanup, hydrogen generation, then it gets compressed, again syngas, methanol synthesis, and crude methanol, then methanol purification. Again, as I mentioned, the high energy demand, low catalyst activity. Why these type of catalysts are really important? Because of this low catalyst activity, intermittent renewable energy supply, anyway. Yeah. So if we talk about all these, based on the methodology, the most important factor is we need to concentrate because there are multiple techniques are available and all other, you see, we are researcher and many, we are trying to identify the different way to solve the problems. So one researcher is working in the area of homogeneous catalysis, another is working in the area of heterogeneous catalysis, one is with acids catalysis, base catalysis. But the ultimate aim is to identify the promising technique for the conversion of the CO2, and our objective is to minimize the CO2 mitigation, right? We have to reduce the CO2 concentration in the atmosphere so that we need to able to serve and save our Mother Earth very safe and sustainable. So future studies should concentrate on CO2 to methanol conversion, which yields more methanol than syngas. Yes, there are certain future objectives as well, and that's why some of the key points that we highlighted here. Okay, last point again. I must require a couple of maybe two more minutes. I just want to scroll down my slides. So this was the basic work. The moment when I joined in the PDU, that time I started first because that see I did my PhD in the area of ionic liquids and their applications in fuels. But the moment when I joined here in PDU, that time first research scholar, she come up with one idea. She said, "Sir, I want to work in the area of wastewater treatment." Then I changed my. I thought like, okay, it's a wonderful opportunity. She was a get qualified, and then we decided to go for the water purification. But instead, interesting thing is that we have successfully executed that project with good number of publications, patents, and one technique we commercialize as well. So, like our target initial, we decided to go for fluoride. Then later on, we shift to the arsenic and some other materials as well. But again, anyway, I don't. I'm just trying to scroll down the slides because these are the ending slides of mine. We identify the problem like in India. We thought like there are many villagers, there are many other cities, they are facing the issues with the fluoride content into the wastewater, and we decided to develop a promising nanomaterial which minimize the fluoride concentration from the wastewater, and it can be useful for the society. This was the motivation. Like presently, 17 states in India have fluoride problem, which also includes Gujarat. This was our statement we made last, that time. But sincerely speaking, yes, it's a reality. Multiple states in Maharashtra and across India and Gujarat, we are facing the problem with arsenic and fluoride, and that's why we decided to go for that. We have developed multiple types of nanoparticles, and then we identify their things. This is the root. Okay, I'm just scroll down my slides because this is something related with the research. I don't want to highlight much research facts. Intentionally, I have kept these slides to just visualize yourself the intensity of the research, that the amount of research that we have done here at PDU. Then kind of study thermodynamics. Yeah. Anyway. See, once we have set a base to go to develop a promising nanoparticle for the laboratory one, then we went for the field study, and we have collected for the samples from the various locations in Gujarat. And I asked her to go for Rajasthan as well to collect some sample. We identify some areas, and we have collected those samples. And then later on, based on that, we identify whatever nanoparticle we have synthesized that given us very good fluoride removal efficiency. And we have compared these nanoparticles with other existing nanoparticles, and we observed few nanoparticles are very good in combination with FeAl, Zn, also aluminum dop ZNA. This also given us a good promising efficiency. So we have commercialized couple of nano, sorry, we went for the patent, and then based on that we have commercialized one technology. Again, I just want to sum up some of my slides, highlighting the facts about what kind of research facilities we develop at PDU with the support of Larsen and Turbo, with the support of DST, with the support of Surgeon India, with the support of Guj Coast, and with the support of some other nearby industries. So we have developed very good facilities here at PDU, and our research group is extensively working in the area of CO2 separation, capture, and utilization. We can see this kind of work we have done for LTTS. Then CO2 separation, yes, DST given us some funding. As I mentioned, 60 lakhs DST given to us, and this is the outcome of that particular project. Then we have developed the technology to convert CO2 into green methanol. Specifically, we have developed ruthenium-based catalyst. There is some uniquenesses there in that catalyst, and I just want to acknowledge my research group and collaborations. As I mentioned earlier, We do have lots of international collaborations and in an Indian collaboration as well. I have just highlighted one or two international collaboration here. So this is the overall group of mine. Dr. Parvati Pillai graduated in the year of, as I mentioned, she has done her work in promising nanoparticle for water purification. She worked in the area of ionic liquid. She worked in the area of, again, ionic liquid with molecular simulation. Ongoing research scholars are there, and many other students, they are associated with me. So I'm very much thankful to different agencies and my postdoctoral supervisor Mika Siranpa and other guys. There are many other members are associated with us. They encourage us and they are the starting point of these initiatives and all. Some of the students involved in the past. Thank you. Any question, please ask. Thank you. Once again, I just said, I just regret my thing. I could not able to make the presentation in line with the let's say agriculture and food industries thing. But whatever I have covered, based on the various case studies, it is directly and indirectly relevant with the agriculture and the food processing units as well. Thank you. Yeah, Dr. Bignore, please go ahead. Thank you.
Thank you, sir. Now we will discuss the questions with
Yeah.
you. Some questions from our participant already drop in chat box. So here I will read first question. Kindly give the some example nano catalyst and its uses.
Okay, wait. Kindly give some examples.
Nano catalyst and its use.
I think I have already covered. There are multiple slides which I highlighted about the use of the
Yes, yes, right.
properties of the nanocatalyst, their uniqueness of the nanocatalyst, and the examples also. And ultimately, see, nanomaterial can be applicable for any application, which includes water applications, which includes bio applications, which includes for CO2, it can be act as a polymers, nanocomposite, everything. And again, if we talk about drug delivery system, there is again also the use of nanomaterials there. For example, cancer therapy treatment. Many, gold nanoparticles and the silver nanoparticles are the proven to treat the cancer kind of virus as well. So there are many examples. But as she asked, Husra asked me about nanocatalyst. See, nanocatalyst means what? It's one side there is a normal catalyst. Now I just want to make, because what is the definition of nano? Nano states that 1 nanometer to 100 nanometer particle size. Or sometime if we are able to achieve 150 nanometer particle size, still it can be considered as a nano. Because that happened because of what? Sometimes we are not following the methodology properly. Only the concept is nano catalyst is having the size below 100. Some catalyst having the size of 250 nanometer or 300 nanometer, that considered as a catalyst. That's why the uniqueness comes. And there are multiple examples. I already highlighted some examples there. Yeah, second question, please. Yeah. So which nanoadsorbent showed higher efficiency in water treatment? Again, it's a matter of research. Again, we have once, see, as a researcher, we have to compare, we have to develop different types of nanoadsorbent, nanocatalyst, and based on that, we can able to conclude. Sometimes, see, I cannot say whatever I have developed, whatever we have fabricated or synthesized, that's only the promising nanoparticle. There are many many researcher across India, including IITs and all. If you go and see Professor T. Pradeep research group and their videos on the website, you can able to visualize. He has developed. Professor T. Pradeep is a very well-known professor and Bhatnagar Sarup awardee also. You can see his contribution in the field of water treatment. He has developed many promising nanoparticles, and that nanoparticles act as a very promising, and it gets commercialized as well. So it is advisable to you. Please refer the website of IIT Madras, Professor T. Pradeep. You can able to understand the entire idea about the various types of nanoadsorbents.
Next
Okay.
question is why translation metal oxide are most commonly used as a photocatalyst, and kindly suggest some novel photocatalytic to be work on.
Sincerely speaking, I did not really work on photocatalysis. Basically, as a part of the slides, I have shown that as a one technique which can be very much impactful. But one of the researcher, Dr. Ravi Tejasvi from our department, He has developed some good, research in the area of photocatalysis. In case required, I will share his connections with the required delegate, and you just have a direct connection with him. He can be able to give you the lots of idea about it. Yeah.
Okay, so from same person, next question is what sort of the concentrator designing expected in the order to harness maximum solar energy?
What sort of concentration or concentrations? Uh, no, see, I think I'm unable to get this question properly, but I just want to give the answer in a layman language. Basically, see, uh, as far as the solar energy is concerned, what I mentioned, I had given you the idea. I have just shown the case studies of the plastic solar cell, right? Because uh, I'm just trying to make you, let's say, encourage into the research. Look, conventional system is there, conventional solar panel is there, and if we go for the plastic solar panel with the use of the nanotechnology, in that case, if I have shown that diagram to you where we have used a TiO2 based design based rod system. That particular coating of TiO2 over the that panel that gives you that absorb the highest amount of the concentrations of an excitation of electrons are happening, and that converts solar radiation into the maximum amount of electrical energy. But if we talk about the design aspect, then yes, we have to think about different materials also, and we need to go for it. It should be a compatibility, should be match between that particular coating material and that that whatever the tube is there, that needs to be matched. Yeah.
Next
I think
question is also
I think only Rohini Singh asked many questions. Okay.
yes,
So
it's related
yeah,
to same photocatalytic hydrogen
right.
generations.
So most
So which
probably,
solvent is
Dr.
most economical, efficient for the photocatalytic hydrogen
Right.
generations?
So I think you can provide my number to Dr. Rohini Singh. Maybe or maybe email ID is there. So if she want to ask me many questions in person, I'm feel free to, I'm always happy to give the answer of all those queries. Wait a minute. Okay. Someone asked me about, sir, could you please explain about your commercialized product uniqueness and innovation? Yes.
Yes, yes.
Again, yeah. See, I can give you some brief about, because some confidentiality comes into the play, and we have signed the ND agreement with the company. But as far as the uniqueness means, what the company already developed one catalyst. They have done some trials at their premises. They realized that that catalyst is not really working effective as per their requirement. So they sent that requirement to us. They discussed that idea with us, and they asked us, "Okay, since you guys are having the expertise in the field of, let's say, catalysis or maybe the solvents and other things, could you please redesign or redevelop the similar kind of catalyst? We'll give you the techniques, we'll give you the methodology. No need to deviate anything from this, but we want to improvise this catalyst for our requirement." So we have done certain iterations, some method change on, some composition things, and we have given them that product, right? And then finally, whatever their expectation was, the catalyst should give us minimum 25 to 30% conversion in terms of CO2. But if we talk about the global benchmark, the CO2 conversion to methanol, if we go with the catalytic route, it only states that 22% conversion. But yes, we have developed the catalyst where we are able to at least touch upon that benchmark and slightly get higher 1 or 2% higher efficiency. So that would be the uniqueness of our product. Okay.
So next question is, can nanoparticles be used for energy storage and they could potentially replace lithium ion battery?
Yes, 100%. That's why I highlighted the importance of amexine and graphene. See, graphene is a well-known material. It is a second, it is 2D nanoparticle. See, nanoparticle is always useful for the energy storage devices. And if we talk about amexine is having lots of applications into the energy storage devices. Recently, we have the work on phase change material as well, where we use phase change material for the energy storage devices. If you go for PCM, then I think, yes, that material can be applicable and very useful for the energy storage systems. we have published, I think, one paper on that line also. You please refer that paper, and in case if any query is there, you please connect with me. I don't mind for it. Yeah, they could potentially replace. Yes, yeah, and this, if you come to PDU, we have implemented the lithium. Apart from the lithium and battery, we are also working in the area of vanadium flow battery and sodium battery. But sodium is not really much that much. But vanadium flow battery, yes, we are working on it, and we have a big setup of vanadium flow battery at PDU premises. Okay, I think there is no more question, right?
Any questions from participant? So you can
Yeah,
drop into the chat box. Otherwise, we will go further.
right. So one more line I just want to
I
add. One more line I just want to add that see. Basically, I just want to say one thing. We are open for the collaboration, and for me, basically being a researcher, I always thought one researcher needs to be help to other researcher. So you guys can explore that possibility, and this FDP is really strengthen that kind of connection. That's why this kind of FDP is happening, and it's really a good platform for all those who just want to build up a good connections with the different academia. So we are open for the collaboration. I just want to give. I think maybe Dr. Nilesh, you can put my number, mobile number or email ID in the chat box so that if anyone have any queries, if after maybe later on, they may ask me or they can connect with me on my email ID as well. Yeah. Nilesh sir, you're on mute.
oh, sorry.
Yeah, thanks.
Uh, Thank you very much, sir, for your giving information session with us, for providing the very nice information about the nanocatalyst and its application in various fields, and how to uh, carbon capture options and carbon utilization options, and information about the CO2 conversion processes like chemical, electrochemical, photochemical electronics, all these methods, and methyl production from the CO2 and its application. You explain very nicely to our participants. I hope our participant will be this information will be very useful and applicable to the research area or future works. So, and once again, I thanks to very much for our accepting our invitations and providing us with your time from your busy schedule. So thank you very much, sir.
Thanks to
And
you also.
we have to
Yeah.
take one photograph with our participants. So please put on your cameras on. After that, I will share one feedback link. I have
Right.
shared feedback link, so all participant can fill it.
Yeah, I'm also thankful Dr. Nilesh Dumore, Dr. Chandra Pal for inviting me and given me a chance to at least address on the intellectual audience in front of intellectual audience. Thanks a lot. Yeah.
Thank you, sir.